Amy, you just missed a lot. Take a break chair. Take a break chair. I learned about. Amy, Spanish teacher fired. Good job, Amy.
She didn't get fired, she quit.
Oh, she's like destitute now.
No, she works at the elementary school now.
Oh, I thought she quit.
No.
She quit.
Wow, my brother told me she quit. Oh, I feel
Hilarious.
I wish she quit.
I
wish she quit.
She don't
What?
All right, let's finish. Alright, example 3. Do you think you got it?
Yeah, I do.
No.
6 and negative.
Can I use my
It
calculator?
is 6 and negative 6.
Yeah, yeah.
Did you get it, Amy?
Aw, I'm sure Amy did. Alright, do you want to do it then real quick? Or
Yes.
okay.
Yeah.
So the position is blah blah. Find the acceleration each time the velocity is 0. So they're telling you they want the velocity to be 0. And they want to find out at what times does that happen. Find out what times that happens and plug it into acceleration. So what's the acceleration each time the velocity is 0? Set it equal to 0 and solve it. If you factor this, you would have gotten t was 1 and 3. So then just plug 1 and 3 into acceleration. And you got negative 6 and 6 meters per second squared. Does that make sense now?
Yep.
Okay, last question, number 4. Again, a particle moves on the number line. So annoying. Below is a graph of the position of the particle as a function of time. So now I don't have an equation. I have a graph depicting the movement. So don't get in your head that this is like,
This is so easy.
right? This is not something moving up and then hanging midair and then falling down. That's not what this graph is. This graph is telling us what's the position as time goes by. So like, not to be dumb about it, but I know gets confusing to people. If I were going to like look at time and look at how this thing moves, where does it start? At time equals 0, where is it?
0.
It's at 0, so I start at 0. At time equals 1, where am I?
2.
At 2, so I move to here. And then I stay there for a little while. Right, so I'm still, and then at time is 2, I'm still here. At time equals 3, I've gone backwards to negative 2. At time equals 4, I'm still there. At time equals 5, I'm still there. At time equals 6, I've gone backwards to negative 4. So that's what has happened. I had a particle start here, move over to 2, move backwards to negative 4. Just so you see like what actually happened. That this graph is not telling you, it's not showing you movement as far as like up and down or anything like that. It gets confusing to people's brains. So question A, when is P moving to the left? When is P moving to the right? And when is P standing still? There's a couple ways to think about this, but the most general way, especially if you have trouble with this, is, remember, left is when velocity is negative, and right is when velocity is positive, and still is when velocity is 0. And if the graph I'm looking at is position, what's the derivative of this graph?
The slopes.
Right, the slopes or velocity. So if I think about the derivative of this graph, I'm looking at what the slopes are. So if this is position, and I want to think about what's happening with velocity, where are the slopes of this negative? Between what seconds? 2 and 3, and also 5 and 6. So the velocity is negative, or I'm moving backwards between 2 and 3, and 5 and 6. I can write it like interval notation like that. Does that make sense? This is like a huge concept, actually. To be able to look at a graph that's modeling position and understand that it's moving to the left when my velocity is negative. So when my velocity, so when my slope here is negative. So from 2 to 3 I have a negative slope, and from 5 to 6 I have a negative slope. So therefore the thing is moving to the right when the velocity is positive, or when the slope of that graph is positive, which happens only once. When? When is the slope
0
positive?
to 1.
0 to 1. And the thing is standing still when the velocity is 0, or when the slope of this graph is 0, which happens a lot. From 1 to 2, and from 3 to 5. Do you get that connection? It's going to come up a lot, especially in the first semester. But really trying to pick out from one graph what its derivatives are.
So is this all we're doing? Like this first
This is
one?
all the physics we're doing for now, yeah. Is that what you were asking? Like,
No, like is this all we're gonna do for like the first one period?
no. No, physics
What?
is
What
like,
type of
that's
questions?
it. We're done. We're finished. We're basically finished positionals.
If I wanted to learn physics, I would do worse questions.
Yeah, exactly. So part B, real quickly, if I'm going to graph the velocity,
Yes, is it?
this is physics too. So if I'm going to graph the velocity between 0 and 1, what should the velocity be?
2.
How do you know?
Because it goes
That's the
up
slope.
2 over 1.
Because it's the slope. So the slope of that line from 0 to 1 goes up 2 over 1, so I should have a line at 2. Between 1 and 2, the slope is 0. Between 2 and 3, the slope is
Negative.
Negative 4.
negative 4? Okay. Sorry, I was 2. What was this at? This is a 2, wasn't it?
Mm-hmm.
Negative 2, negative 4. So the slope is at negative 4. Between 3 and 5,
0.
it's back to 0. And between 5 and 6,
Negative 1.
Negative 2.
negative 2.
Oh.
All my ends should be open, but it's not something people are going to be real nitpicky about. Does that make sense? It's basically the same thing we just did, but we graphed it. We found out over here when the velocity would be negative, positive, or 0. And now we just went and actually graphed those slopes. And just to remind yourselves what speed is. Remember what speed?
Magnitude of the velocity.
Magnitude of the absolute value of the velocity. So the speed graph I'll do in green. You're just going to take anything that's negative and make it positive. So the speed graph is this, and this, and this, and this, and then this. So the speed graph wouldn't have those two down there. They would pop up to 4. Alright, that's all the physics you're going to see. Honestly, that's almost the extent of it for this class. We'll get into some more like nitpicky derivatives starting tomorrow. So let's just try a couple for homework. Oh my gosh, this is so hard.
We don't want to leave Amy behind.
Oh my gosh.
They're such selfless people.
And like, seriously, it's not my fault that you're overwhelmed in your other classes. It's Watson's fault.
It's not Watson.
It
No,
is
Watson,
Watson's
it's
fault, I'm not gonna
It's
lie.
Wilson.
Oh, it's Wiltie's fault then.
Who's a... This isn't it.
So gross. I always do that.
You're always going to feel that way about Wiltie.